is it found in geometry? And also, it can be used more than find a side. You can use the Pythagorean theorem in a different way other than just finding the side of a triangle. So yes, I do want to go over the actual Pythagorean theorem first with you, but I don't know if I've harped on this enough with you guys. You can't just use this bad boy anytime you want. Like if I just throw a triangle out, here's two sides, find the third, you cannot always use Pythagorean theorem. It can only be used in a right triangle. So let's make sure we are very clear with that. It's a great thing to use, but only if it's a right triangle. If it's not, you're out of luck until the end of the unit, which I'll show you how to do it in a non-right triangle. But for now, it's got to be in a right triangle. And we know, right, a squared plus b squared equals c squared. I want to put some vocabulary terms to a and b. What are those sides called that you plug in for a and b? Those are your legs. Look at you guys, huh? And then C is going to be your hypotenuse. Now, a lot of people always say, oh, hypotenuse, biggest side, biggest side. Yeah, it's the biggest side in a right triangle. How do you find the hypotenuse if no sides are listed, though? Across from the right angle, always, always. Forget about it's the longest side. It's always across from the right angle. All right, so here we go. Where is it found in geometry? Example 1. Find the perimeter of this. Oh, welcome back. Welcome back. Parallelogram. You thought you were done with it. Nope. Find the perimeter of this parallelogram. Oh, period 3. This was just mass confusion, almost borderline embarrassing. What's one side length we already know of the parallelogram? Oh boy. What's one side length we already know of the parallelogram?
11. Not 9. It's not what you don't add to. Where does 9 stop? Does 9 stop where that other dash is? Yeah, telling you that.
Yeah, it's parallelogram. That's not. I can't tell.
Oh, yeah. Now it's what?
Now it is. All right. So we got 11, which means since it's a parallelogram, I got another side, don't I? Opposite sides congruent. It's 11. And now what about the two other opposite sides that are also congruent? Well, we're going to do Pythag for that. All right, I need to find do Pythag to find this missing side. All right, turn it over to you guys. Can you guys set up, one of you guys set up Pythag for me? All right, set up Pythag for me here. Gabby, go ahead.
2 squared plus 6 squared plus c squared.
Excellent, you got it. There you go, equals c squared. Simplest radical form, please. Your calculator will do that for you. So when you do have the simplest radical form there, let me know. Use your calculators. Take the square root on each side. When you have it, let me know. Oh, Gabby, going back to you.
2 radical 10.
Good, 2 radical 10. So one side is 2 radical 10, meaning the opposite side also 2 radical 10. Let's find that perimeter now. Let's find that perimeter. And the perimeter in simplest radical form, Josh?
22 plus 4 radical 10.
Yep. A couple of kids last class had a question like, is that correct? That's what my calculator's giving me. Yeah, you can't go any further. All right, I can only add these if the 22 had a radical 10 attached to it, which it doesn't. So this is as far as it goes, and that is the perimeter of my rhombus. All right, so it could show up in quadrilaterals. Here's another way we could use Pythag in geometry. Here he is back again. He's going to make more and more appearances in semester 2. Big Al. He wants to avoid walking through a pond. Who wouldn't, right? You don't want to get all wet. So here's what he does. He goes 34 meters south, 41 meters east. Do I need to get the navigation compass out, or are we good? East, we all know where we're going. We'll see, we'll see. All right, so he goes 34 meters, whoop, down, right, 34 meters. Where's he going here, right or left now if he's going to the east? He's going to the right, yep. 41 meters. Now I want to make sure we're clear on what we're asking here. What we're asking. How many meters would he have saved if it were possible for him to walk through the pond? All right, so there's a pond. All right, there was a pond here, obviously. Look at my pond, beautiful. And he didn't want to go through it. So we walked 34 meters south, 41 meters to the east. How many meters did he walk by avoiding the pond? 75, right? 34 and 41. So he's already walked 75 meters. But I want to know how many he would have saved if he walked through the water. So everyone okay on the question? All right, because we are going to find the length of the pond, but that's not my final answer. We're going to see how much you would have saved by walking through the pond. All right, so let's find out how long the pond is. And what do you got for me for Pythagorean theorem here? Ooh, 9, Ian. Save yourself here.
34 squared plus 41 squared.
All right, good. All right, be prepared. Just a warning, I'm going to get fired up here in a second.
Is this a right angle?
Yes, it is.
Straight down that street.
He went south and east, right? You good there? You got that? You good? No curvature there? You didn't walk up a hill or anything? Okay. Yes, Matt, it is a right angle. So we got c squared equal to, all right, here's where I'm going to get fired up. For the first time this year, this is happening. Everyone gets c squared equals 2,837. Everyone knows, yes, I take the square root of both sides. And I did that on my calculator as well. And I got 53 and change. Is that my final answer? No, and I'm asking you that because if it's not your final answer, you do not round it on your own. The only thing we round in here is the final answer. And here's why. If, say you round this to 53 on your own, that may throw off your final answer by a tenth or two. All right, so do not round until the very end. So what do I do with it then? Stretch your wrist out because you're about to write the full decimal down. All right, write the full decimal down. So C is equal to that 53.26349. And hey, I'll even accept if you just write square root of 2837 and you don't want to write it. That's fine. But you cannot round it on your own until we're done with this problem. Okay? The only thing that's get rounded in here is our final answer. All right, so now we know how long the pond is. Now let's talk about the meters saved by Big Al. If he did walk across the pond, he would have saved how many meters? And how are you finding that? I don't want to know what it is. How are you finding it? How are you finding that answer there? 2, what do we got there, Zoe? Yep, I got you. And if you guys haven't been exposed to this last year in Algebra 1, you do not need to retype that full decimal number. You can just type 75 minus and then highlight it and hit enter. And then I know I learn every day here. You could also hit answer, I guess. Some kids told me you could hit answer. That would get your previous answer in there. Okay, so, but you do not need to type the whole thing in. You can just do a little copy paste. Now you can round to the nearest tenth for me. And how many meters did Big Al save? Nearest tenth. Will? 21.7 meters. I'll also address this now. I don't care if you put units or not. I don't. All right, I'm not going to be the one. Well, you're an honor, so you should put unit. I don't care. You want to keep the units. You want to throw an M for meters. You want to write the word meters. Whatever floats your boat. All right, I'm never going to take off for it. All right, we all good? 21.7 meters. All right, whoever you had for Algebra 1 last year, time to make them proud or time to make them disappointed on this one. All right, let's see how you do. All right, just your basic right triangle. You know all three sides. We're looking for x, so we got to use Pythag here. Gotta. So first, can somebody set it up for me? Set up Pythagorean theorem. Zoe, back to you. Okay, stop right there for me. Now, when I write x minus 4 squared, let's make sure it's in parentheses, because if it's not, it looks like I'm just squaring the 4. All right, Zoe, go ahead. Equals x squared. Perfect. All right, so good substitution of Pythagorean theorem. We already know 8 squared. I'll take care of that. That's 64. Here's where you're going to make your Algebra 1 teacher proud or disappointed. How do I handle x minus 4 squared? How am I going to handle that?
Distributed. Yeah.
Good job. Now you made them proud. You would have made them disappointed if I heard this. No, that's embarrassing. All right, that's embarrassing. All right, come on. I think they taught you better than that. Yes, you're going to do x minus 4 times itself and double distribute. X times x times negative 4, and then you're going to take the negative 4 and distribute it. Go ahead. I am not going to do that work for you, but I am going to ask somebody what you got when you end up combining your like terms and everything. All right, when you combine, I just want x minus 4 times x minus 4. What did you end up with after you're combining like terms? What did you end up with there after combining your like terms? We only got a couple people going today, huh? Will, what'd you get? Plus. Negative 4 times negative 4. You good over there? Okay, feeling all right? Shake it off, Will. Shake it off. Suck it up. You got it. There's going to be a chance for redemption today. I can guarantee it. All right. Wow. What is this on the left side? That's garbage. Let's clean that up, please. Whoa. That's making me nervous. Let's put the x squared first, the negative 8x next, and then how about combine my like terms and get 80 there? Let's turn this over to you guys now. What would you like to do next to solve for x? Doyle?
Move the x squared and negative 8x over, so to have 8x equals 80. That's what I did.
Okay. That's fine. We could do that. A lot of people today have been saying move this x squared over so it's equal to 0. And then no matter what you do, Doyle's way or move the x squared, what's going to happen to the x squareds? They're going to see you. See you later, right? See ya! They're gone, right? They cancel each other out. So everyone see that. No matter what you move over where, right or left, the x squareds are going to cancel. So I'm going to be left with negative 8x plus 80, not equal to a ghost or a frown, but equal to 0. Or if you move the 8x over, it's equal to 8x, like Doyle did. All right, but either way, let's solve it now. Let's solve it for x. You ladies all right up here? Okay. You were going to distribute that exponent, weren't you? Yeah, that is embarrassing. I can feel that. They're so proud over there at the middle school now, I'm sure. Honors, man. They tell me. Olivia, what'd you get for x? Good job. Yep. And that makes sense. It's positive. Only can have positive sides. Whew. X equals 10. Good work. Questions, comments? Any there? All right. So I told you also Pythagorean theorem can be used for more than just finding a side. And here it is now. All right. Way back in the day when I liked most of you, I introduced these 3 types of triangles: acute, obtuse, and right triangles. But to be able to tell me if a triangle was one of those three, you had to know the angle measurements. The angle measurements. Not anymore. You can know the sides now. If I tell you all three sides, you can tell me if it's acute, obtuse, or right. How do we do it? Here we go. Look at the first example. I'm not going to read everything in that chart. That's for you guys to look back on if you forget. I have a triangle of 9, 12, and 15. So it's scalene at least, right? We can agree there it's scalene. But now, using Pythag, you can tell me if it's acute, right, or obtuse. How? Here we go. You take the two smallest sides, and you plug them into A and B into Pythagorean theorem. So A squared plus B squared. You take the two smallest sides, plug them in for A and B in Pythagorean theorem. Leave out the equals. Leave out the equals because we don't know if it's equal or not. Leave out the equals. And then I plug the longest side into C squared. All right, so I take my two smallest sides in for A and B, biggest side in for C, and now I compare the two. All right, compare the left and the right. So it's 81 plus 144 on the left, and on the right I get 225. Keep going. Add those two up on the left. Oh, what do you notice when you add them up on the left? You also get 225 again, right? All right, so I notice that the A squared and B squared side was the same as the C squared. Isn't that Pythagorean theorem? And we talked right at the beginning of class, Pythag only works for right triangles. So if they're both equal to each other, both sides, that's Pythagorean theorem, which only happens in a right triangle. Okay, so that one's going to be sides of a right triangle. Now, are they always going to be equal? Absolutely not. How do we go? What if it's not a right triangle? How do I determine if it's acute or obtuse? Take a look at the second example now, 10, 11, 13. Again, take the two smallest sides, plug it into A squared and B squared. Take the longer side, plug it in for C squared, drop the equal sign. And let's compare the two. So I get 100. Ooh, 11 squared was always the tough one in the multiplication table, right? Or was it tough? Was that the toughest, or was 12 times 11 the toughest? Good talk. All right. Anyway, sorry. Try and have more of a discussion with you. Sorry, never do it again. 13 squared, that was never on the chart, right? Had to go to the calc for that. 169.
What chart are you talking?
You guys never had a multiplication? Like you had to do it real quick?
Now that we had the square.
2 times 3, 3 times 2,
like
4 times 8. How fast you could do them? How many you could get in a minute?
Yeah, but it didn't go over
That
like
stuff?
5.
What's that?
It didn't go above like 5.
Didn't go above 5. How'd you make it here then?
Like 5.
I had to at least go 12 times 12.
Yeah.
That was the highest usually. Traditionally, that's the highest. Yes?
I went to 10. No,
Had to go to 12. No?
I don't think it went to 12.
Mine went to 12 in like third grade.
It went to 12.
Yeah, I think it went to 12. I don't know what we were doing in math class back in the day, but guys stopped eating the paste or something. All right. I think usually it goes to 12 by 12, but all right. So here we go. We got 221, 169. All right, it's definitely not a right triangle. So how do I tell if it's acute versus obtuse? If C squared is less than the A squared plus B squared. If the C squared is less than the other two, it's acute. If it's more than the other two, it's obtuse. So this one would be an acute triangle because it's less than the A squared plus B squared. All right, so if C squared is less than the other two, it's acute. If it's bigger, it's obtuse. All good? All right, next part. Oh, I love this question because it's going to bring you so much misery. Go ahead and graph triangle XYZ. we have done a lot of problems where I could say, hey, is this isosceles equilateral scalene? And we'd be comfortable doing it. But look at the directions now, acute, right, or obtuse. And we don't know any of the angle measurements. But I just showed you, if you know the sides, you can do Pythagorean theorem to see if it's acute, right, or obtuse. But I need side lengths to plug into the Pythagorean theorem. So how am I going to find those side lengths? Come on, yep, distance, anybody? Distance, high fives, nope, nope, pound, nope. Okay, never mind, didn't think so. Yes, distance formula. So just a little reminder from our midterm. I am not going to miss this formula next year. Oh, but you'll be begging for proofs next year after you get a load of algebra 2. I don't have the time for all of you to do all 3 sides, so we're going to break it up into groups right now. All right, we're going to break it up into groups. I'm a little nervous with this one up front, but after today, you guys have XY. Come on, you got it. You guys have XY. You guys there, come on, there's 5 of you. Let's go. And maybe 4.5 with Matt, but X, we got ZY next. All right, ZY. And then 2 groups here. You guys have what's left over, XZ. You got XZ. Please be in agreement before you announce to the class what you think it is. You guys have, what did I say? Yeah, you guys have XZ, the last one. So you All right, here we go. Make sure you mark whatever 2 sides you weren't responsible for. Make sure you jot them down, please. Hey, group 1, what do you got for XY? Square root of 29. Excellent. Way to go. All right, ZY group, what do you got for me back there? 2 radical 5. Yeah. XZ group. Holy jeez. How about a radical? Can we leave it in radical form?
13.
Radical 13. Thank you. All right, we're good now. And then that actually brings me to a good point that Doyle did that, because now you got to put the 2 smallest sides in for a squared and b squared. And some of you might look at these and say, ooh, which out of these 3, which 2 are the smallest? Do what Doyle just did. Look at the decimals. Okay? Look at the decimals of each and compare them. All right? Look at the decimals. Radical 13. Right? Radical 13 is one of them, so I'm going to go radical 13 squared. And then out of the which one's smaller, 2 radical 5 or a radical 29? 2 radical 5. And remember what I suggested yesterday to watch out for? When using your calculator, what am I going to do with 2 radical 5? Put it in parentheses, correct. So add that to 2 radical 5 all squared. And how does that side compare to taking the longest side, radical 29, and squaring it? I have 33 on the left side. The a squared plus b squared side is equal to 33. And on the c squared side, I have 29. So the c squared side is less than the a squared plus b squared side. So we can say this is an acute triangle. And we can also say it's scalene, right? After we found the distances. But for this problem, acute. All good? All right, one more. I got this off an old Regents question. And there he is again, Big Al. He brought his younger brother with him, little Mike. Big Al's like, hey, I think these two bad boys are congruent. The younger brother's like, I think they're similar. Are they both correct? One wrong, one right? Both wrong. Right? Well, let's talk about Big Al saying they're congruent. I have no idea right now. Remember, we had 5 methods to show triangles are congruent, and I don't have any of those 5 right now. I don't. But can we find some additional information after today's discussion? I think so. I think you can find the missing side of the first triangle and the missing leg of the second one. All right, so right now I can't tell you if they're congruent, but maybe if you find me some more additional info by doing Pythagorean theorem, we could talk. Missing side of the first triangle. I'm playing with fire right now. Missing side of the first triangle. Charlie? What do you have?
13 centimeters.
13 centimeters. Thank you for this one. Good. Missing side of the second triangle. Gabby? 12 centimeters. Good. All right. Now that I have this additional info, do you see one of the 5 methods now? Are they congruent? Oh, yeah, they're congruent. Absolutely. So, yes, triangles are congruent. Of course, explain why. You can't use any of the 5. There's a couple you don't have enough information for. But of the 5, give me one of the reasons that you do have here. What do you got for me? 8, Josh?
Side.
Yeah, that's what everyone's been going with today. By side. What else could have worked? Side, angle, side. And a third one could have worked. HL. Yep. What could not work? Angle, side, angle, or angle, angle, side, because I don't have 2 pairs of angles. I only have the right angle. All right, what about the younger brother here? Are they similar? Are they? Okay, all right. So yes, good job. Triangles are similar. Why? Remember that half method? Everyone thought I was nuts. Why is there a half method? Yep. If they're congruent, they're similar. Or anybody else? Other methods? Right? So side, or side, angle, side. All right, I just couldn't use angle, angle. But I like the triangles are similar because they are congruent. I like that. And that's a wrap. Just do me one favor. Pay attention to the rounding directions at the bottom of this page, please, because that's how my answer key is. All right, it's rounded to those certain measurements. Whoa! Let me just show you one of the problems I assigned tonight and how you can still use your calculator to do it. Okay, I assigned this basketball hoop question, and you'll notice it's 1.5 feet here, 3 1/3 up here, and you have to do Pythagorean theorem with those. Are you guys aware from last year you can take your NumWorks calculator and put it into that format? You guys know how to do that, so you can type in 1.5 or 3 1/3 real quick if you don't. Get this out of the way. Clear this out. Clear. You just hit your division key a couple times, 1, 2, 3 times, and then you can type it in. Okay, so to get that mixed number as it's called in there, that's how you do it.